Okay, hi. My name is Bryn, and welcome to the Voxel File channel. So this is a channel where I am creating a foundation layer in order to eventually create a video game. And hence the channel's name. The video game will have to do with cubes and the interaction between cubes in order to create a larger world. Now I do have a little bit of a script this time that I'm going to go over, but mostly the code is the script, so let's switch over to that. So a lot has happened since the last time I had left off, and the most important thing is now I have something drawing to the screen. So you can see if I type cargo run, I get a triangle. And this is miraculous how I'm getting this triangle, because I have created an API which reduces the bulk of Vulkan by nearly half, if not it makes it a third, and that's truly insane. So if I go down here, it's about 417 lines of code. This is verbose for even more than a minimal example would be. I could probably get this down to 300 lines of code if I wanted to. And a normal Vulkan hello triangle would be about 1,500 lines of code. But the most important thing is that I have not lost any expressiveness in the things that I can do. So let's start with executables and executors. So you see here up at the top, I have an option of an executable with an anonymous lifetime, and it's set to none. And then I have a winit event loop. This is just the event loop for the window. And inside of it, when I have a redraw requested, then I set the I don't set the executable, I get a mutable reference to the executable, and then I invoke it like a function. And then you'll see when the window is resized, then I get the resolution. I create a new swap chain based on the new size, and then I create an executor. I record into that executor using all of the variables that I need, which includes semaphores, the pipeline, the images, the buffers, etc. And then I create an executable with executor.complete. Now, the interesting thing here to note is that executors create executables in the graphics, in my graphics world that I'm creating. And that executors are something that you record to, and that executables are something that you run over and over and over. So let's take a deep dive into what is exactly happening here. So if I go to task, which includes the executors and executables, I can see I have an executor that has nodes, it has a submit, it has a present, and it has an optimization function like I went over in one of my previous videos. So executor has a number of functions. The most interesting one is probably the add function. So it takes a task, which has a couple generic arguments, and then it converts that task to a node by boxing its variables in the structure onto the heap. It also takes some submits structure, and then it just puts that into an option, and same with present. And then in complete, what you can see is that it destructures. It gets the resources from the device. It makes sure that the swap chain that was provided in present exists, if present was provided. Then it creates a command buffer, a Vulkan command buffer. And then it creates a fence to be used for synchronization. And then it returns the executable. And so the executable ends up being very similar to the executor in that it is a series of nodes with an option of having a submit and a present, as well as a Vulkan command buffer and a Vulkan fence. And what happens if I go back to here is that when you call record, with this large structure here that has all the useful information. It just destructures that and calls record update and record draw. And then it does executor.submits and executor.presents. Essentially what is happening here is that it's recording a series of tasks, and tasks are a series of commands into the executor, and then it's saying I want to submit those commands to the GPU, and then I want to show the results to the screen. That's what submits and present is doing respectively. And if I go down to record draw, actually no, I will go down to record update first because it is what comes first. It's very similar to what I showed in one of my previous videos, is that I'm just taking the vertices and I'm writing them to the staging buffer. You can see that here. And you know what buffer it's being written to because it says buffer 0, and that there's the first resource, or the 0th resource is the staging buffer. And then I'm writing at index offset the indices to buffer 0, which is the staging buffer. And then this really comes into action here, where I have the staging buffer and the general buffer as resources. And then I write from 0, and then I write it to 1, so I'm writing from the staging buffer to the general buffer, and I'm just copying the entire buffer to the copying the staging buffer to the general buffer. And then in record draw, which is what comes next, I have an image, the present image, and I have a general buffer which I'm passing as the resources. And then I have a pipeline barrier where I am essentially transitioning the present image into a state where it can be used in order to draw to it. So basically I'm saying I want the image layout to go from undefined to being a color attachment. And color attachment just means something we're going to be using to draw to. And then I set the resolution, which behind the hood, if you know, it actually sets the viewport and the scissor. And then I just write start rendering. And under the hood, this does not use render passes, and I will go into that. This is using the dynamic rendering extension, which has been added to Vulkan 1.3. And then I just set the pipeline. I draw with a vertex count of 3, and then I end the rendering, and then I add another pipeline barrier, and in this case I want to transition it from color attachments to present, so that goes from a format where we can draw to a format where I can show it on the screen. And so these are the commands that are executed, and you will see that in the commands, so you will see, in fact, let's go to task first, that it takes a closure or a function which takes a mutable reference to commands as a parameter, and it returns a result which has nothing in it. And then it takes some n number of resources, and then it just stores the task and the resources in the structure. And you'll see when I go to commands that it's very straightforward. So commands is just a special object which contains a reference to qualifiers and a reference to a VK command buffer. So the commands object is very much tied to the executable, and that's what I will go into further. But you can see behind the hood, I'll show one command. I will show the start rendering commands, and you will see that what I'm doing is doing a lot of destructuring, getting the resources, and then I'm just converting, as is a lot within the internals of this API, I'm converting from a format that my API accepts, converting it into the more verbose format that Vulkan uses. And so you can see, for example, I'm getting the clear color from my API, and then I'm converting it to a clear value for the Vulkan API. Very similar happening with the depth and rendering attachment, the depth rendering attachment. These are the color attachments. And then I get the render area, and it's as simple as passing a rendering info KHR to the command begin rendering, and that replaces your render passes and your frame buffers, which, long story short, just makes my life a hell of a lot easier. If you don't know, rendering passes are something for mobile GPUs, so something like would be on your phone right here. It's so that GPU can anticipate what the commands or the framework in which those commands will be sent to the GPU, so that it can better optimize. And that's why phones are able to render things so quickly for their tiny size. I don't need that on a desktop. I don't need frame buffers, which is a special place on the GPU where the things I'm going to draw to live. I don't need any of that. I just need the image, and then I need to show that image to the screen, and that's exactly what I'm doing. So, moving on, I want to go into what the hell is a qualifier. Now, this is really interesting. So, if I go back to task, you can see right under resource, I have a qualifier. And you can see that unlike the last time I showed this, that resource is now taking a function which returns the type of resource that it is. And then it just takes the access to that resource. And then on resource, I can call resolve to resolve that function that I sent. So basically it's converting the function which returns a buffer into a buffer in the case that the resource is a buffer resource, and then it returns a qualifier buffer. And that's just what qualifier is it's a qualified resource in the eyes of the API. And if I go to executable, what you can see is happening is that at the time where I'm executing the commands, so I'm basically creating the commands object and then sending that to the task so that it can record the Vulkan commands into the command buffer. I'm going into the resources, iterating through them, resolving the resources, collecting that into a vector, and then supplying that to the task. And this is the reason why. So if I go to main and I scroll up a bit, you will see that I have a general buffer, which is an identity function for just the general buffer handle. Same with staging buffer, but present image is a little different. So you thought present image was just an image, but you're wrong. It's a function which acquires the next image from the swap chain. And I'm not totally sure on the syntax, so don't judge the syntax yet. Right now, swap chain is a opaque handle similar to buffers and images due to lifetime issues, and the reason why is because you have to supply the swap chain to the present image closure, which has to have the lifetime of the executable, which is why it's in this scope. And then you have to be able to write to the swap chain while the present image is still borrowing the swap chain. So basically what you get is here you would have a mutable reference being dereferenced to write to, where an immutable reference already exists. And how this is solved is by turning swap chain into an opaque handle and then putting it inside of a Rust cell. If you don't know what a cell is, just leave me a comment and maybe I can go into what that is in the future. But think of it like if you know what a mutex, it's like a single threaded mutex is. But essentially what it does is when you do not have mutable access to the object inside the cell, you can modify what's inside the cell with immutable access. So the trade-off there is that it's guaranteed to only be allowed in a single threaded environment, and the logic there is the reason why you can modify something in an immutable way or in an immutable context is because the single thread can only be one point in execution at any time. So I can't be calling present image at the same time that I modify the swap chain, because if those two things happened at the same time, then the program might crash. There could be undefined behavior, who knows. But that's not allowed because I'm using cell. Cell is only allowed in a single thread, and so I know that only this line or only this line will be executed exclusively from each other. So that just solves some lifetime issues. But essentially what's happening is when I supply present image to the task, later when I go and I execute the executable, then it still has a reference to present image, and when it needs the present image for the task, it will get that image from calling acquire next image, and then and the reason why you want to do that is because the swap chain has multiple images. So there's not just one image to draw to, there's 2 or maybe 3 images to draw to. And the reason why you have that is called back buffering. So instead of just drawing to the screen as the screen is displaying it, what you do is you draw one thing to the screen, and then you draw to, on the GPU, you draw to another image, and then you swap those out. And the reason why you want to do that is so you don't cause tearing. It can also prevent a number of other problems on the GPU if you are doing that. But yeah, so essentially I have an executable which is created through recording to an executor, and that executor has a number of tasks which I can record drawing or generally GPU related commands to, and then I can resolve these resources into qualifiers when I call the executable, when I invoke the executable. And the final result is, with a very simple API, I can draw a triangle. And this is an amazing start. I'm so excited for the future. I didn't even think I was going to be able to get the triangle drawing to the screen this quickly, but I'm so glad that I'm going to be able to. The next steps are going over how I do buffers and being able to supply those buffers to the shaders so that I can get additional information in the shader code. And I will be so happy to show that to you the next time I post a video. So if you aren't already, feel free to subscribe to my channel if this was something that interested you. And besides that, I'm so glad you had watched and taken the time to watch my video. And I hope you have a wonderful rest of your day. Thank you so much.